At this note, it's time to start our finally start our panel discussion. So I invite all the panelists to join me and speak their mind. So I guess to kick things off, I just wanted to ask you if, so there were a lot of awesome talks about different aspects of performance, but it seems like a lot of them, they actually would very much benefit from leveraging work of others. Like, for example, when you have certain optimization that you would like to perform automatically, you would probably benefit from knowledge of profiles. And when you build profiles, you would potentially also benefit from knowledge of high-level constructs. And so instead of focusing on just low-level primitives, you can actually reason about the efficiency of the algorithm. In fact, just as an example, Infer, for example, static analysis tool that we use at Facebook, can tell you about complexity changes. So when you make your algorithm to go from linear to quadratic, Infer will flag you and tell you that it used to be linear, now it's quadratic. You probably want to fix this or at least look at it. But then again, without the profile information, you cannot really estimate the impact that you're going to have in production. So I'm just curious if you have any thoughts on how we can leverage each other strong, aspects to make our pipelines more efficient, smarter, and more scalable. Anyone has any thoughts?
I can jump in. I don't know. Can you hear me?
Yep.
This is Stratos. So I think the answer is standard APIs. If people are publishing their APIs and they're easy to use, kind of as a black box, then we can avoid solving the same problem across different kind of, let's say, areas. And definitely monitoring and getting performance counters and all of that is something that we all do. And so there's no reason to keep repeating. There is a reason, but there must be some common part that you don't have to re-implement every time across all these different systems that we're doing. And so I think carefully thinking about those APIs, especially in big organizations, can pay off.
Yeah, I totally second that. I believe that efforts like OpenTelemetry are extremely invaluable because we as an industry, I think we should definitely focus more on building an ecosystem versus building just tools, because I think we focus oftentimes on building tools that work in isolation, but do not necessarily benefit from integration as much, just because the APIs are completely different or just non-existent.
Yeah, I think like you brought up earlier, having standards-based data models and standard ways to exchange data could help us all build on everybody else's effort, right? We can build on each other's effort. There's no reason that we should all be building this ground up by ourselves. So at least some of the work we've been doing, I think the agents are all open source. People are free to send their PRs if you want to add capability. And more importantly, actually, I forgot to mention earlier, is you can run this anywhere. Like you could run it on your workstation. The only thing is you have to go back to the console to go look at it. But the profile format itself is standard, right? So we are taking baby steps towards that, I think. But yeah, just sort of everybody coming together on standard format, standard APIs would make the community development a lot more easier.
Yeah, definitely. I hope that eventually we'll at least be able to get closer to something like we have in compilers, where there is a clear separation between front end that generates something that is turned into intermediate language, which is standard. And then because of that, you can have a single backend optimizer that takes that intermediate representation to do all sorts of analysis and optimizations without regard to what kind of profile data, for example, you have and whatnot. And on a related note, I'm curious about your thoughts on machine learning applications for the performance space, because even though it's an overhyped thing for sure, even CPUs actually use AI and pretty advanced machine learning for branch prediction, for example. So I wonder about your thoughts and opinions on usage of machine learning for performance optimizations.
Yeah, you also mentioned earlier, right, at the Amazon Code Guru, I think they apply some of this within their internal performance data. So I think we are starting to see some of this being more widely available for everybody. But it's in very early stages. I think there's also some effort on having machine learning in compiled optimizations. So yeah, I think there are efforts moving forward in several fronts, whether it's in profile analysis or actually in code generation. Like I spent a lot of time doing hand tuning of code, last 10, 15 years. I think a lot of that is going away and getting replaced with more effective compiled optimizations. They were always available, but you still needed some amount of hand tuning. But that seems to be becoming more automated now. I think, applying machine learning or any other automated techniques for analysis, and again, like how you brought up earlier, sort of making this push-based something strong with your service, go look at it, would make all of our lives much more convenient, I guess, in running these large-scale services.
Yes, the reason why I think it probably even looks somewhat promising for some of the areas is just because it has this ability to generalize concepts, which we as human beings have pretty much built in. That's the reason why performance experts are so invaluable for our work, just because they are able to actually, think at a high level of understanding, and instead of just focusing on optimizing some unnecessary primitives, which is why I was personally extremely excited to hear about the Apple's investment into building their own DSL for modeling business domain primitives for performance analysis. So they have a DSL that is built on top of Lisp programming language, and which allows you to model things. And then when you profile things, instead of getting a low-level details about your allocator allocated this many bytes, or you call this malloc thing 50 times or whatnot, you actually get a much better understanding of you performed unnecessary network requests, or your vector is doing a lot of allocation, so maybe you should increase its initial size or whatnot. So you can leave the abstractions even higher than that. You can say maybe you're doing some inefficient GraphQL requests or something like that. And I just believe we lack as an industry this ability to describe the expert knowledge in a unified way, so that we can share it across different systems, because I see no reason why design patterns and inefficiencies that we have in mobile world cannot be translated in server-side world. If allocations are bad in both places, unnecessary blocking operations and all that stuff is both it hurts everywhere. So, or leaking memory and all these things, they are not useful on any of the platforms. So it seems like we could definitely leverage a lot by having this domain expert knowledge being encodable, and which is why I'm very excited about the efforts that also Stratos was talking about building these primitives that can be used to build higher level data structures. So I'm curious if anyone else has any experience with ability to codify domain knowledge such that it can be automatically applied for analysis of the vast amounts of data that we get every day.
I think one thing that's interesting is that, debug information. To me, this, I don't know if it's exactly like that, but the idea of mixing debug info that we use for debuggers, for profilers, and with this DSL that you're talking about, and having that be something that's available so that tools can replicate this data, I think is a very valuable thing. I mean, to me, it's just one more step in making it more logical, giving it a business operation. You did 5 things. In fact, this is one thing that I've realized developers find much easier to work with. If you told them they spend 2 milliseconds in a function, it's very difficult. But if you told them you operated on this, let's say you're operating on a byte array of images 50,000 times, and the developer is like, oh, I only had to do it 5 times, then you have communicated some information to the developer, and the developer can go and say, oh, I know why it's happening 10,000 times more, or anything like that. I think proxies I think Rico said something earlier that I picked up on in his talk. Time is diagnostic, and proxy metrics that can inform you about operations, whether it's business operations or other logical things, ends up is a better way of, I think, driving developer incentive. I've noticed that when we can associate it with something they care about, other than just saying milliseconds or bytes allocated, it gets you drive much higher gains and perf improvements.
Yeah, I absolutely second that, because even like the challenges of communicating the impact of the regressions it's hard to underestimate them, because it would seem like, oh, we have such an amazing amount of data, we can always detect all those regressions. But the problem is that when we file those tasks, so we say that there is some millisecond regression in one of the functions, nobody looks at that stuff. Because it's, first of all, it's not even clear if it's something that is impactful, whether it's reasonable, and unless you are, first of all, able to have some sort of proxy to estimate the impact, especially ideally on real world, where you can communicate in a language that developers understand instead of just on low-level primitives that compilers are supposed to work with, it can help a lot in terms of driving the fixes and adoption of best performance practices. And I'm actually wondering if maybe Mani has some thoughts on this, because I would imagine that when running these programs, it's important to communicate the impact to developers about their performance regression. So how do you deal with that challenge, Mani? Oops, looks like we've lost Mani. That's a bummer. Okay, but maybe someone else has any thoughts or experience with communicating the regressions to users, to developers, I guess, in our case.
I think, yeah, like we get like this kind of regressions all the time, like in our GitHub, like users file this, hey, this function was just performing fine on .NET 3.1, but when I got to .NET 5.0, there was this regression, and well, it turns out that we looked into the assembly code and there is no difference, like it's exactly same, but just the thing is that maybe there was some functions or methods that got added before that in the memory, and now and that changed the like the code alignment of those methods. So it's very difficult, I guess, to convey that, like there was no change in your code per se, but just because of this other side effects, there is this regression that got introduced. Probably we should do more in like like optimizing loops or whatever that is relevant in your function to get like to erase those regressions, I guess. But yeah, like I think like we see that all the time, and it's I think like very difficult sometimes to convey to the user like what was the like reason of this.
I'm actually curious. So since you're operating on such a low level where you essentially always have to deal on the level of instructions, I would imagine that the amount of noise you have to deal with must be the biggest one, just because obviously any tiny CPU throttling or context switch or anything like that is completely, it's a game changer. If we are measuring some Hadoop workload, nobody cares about number of context switches or some clocks running in the background, or even if you open the Photoshop, it's probably not going to affect your Hadoop computation that much. But on your level, it's extremely important. So I wonder if you have any tricks and tips for reducing the amount of noise and getting very precise measurements.
Right. So, I mean, like this is the exact point that we are trying to work on. So, like in my presentation, I was mentioning about those micro benchmarks. There are like 1500 micro benchmarks, and there are like some of the benchmarks are very unstable. Like sometimes we'll see there was like 30% improvement in one of those, although like nothing changed around that, and then sometimes they'll just like drop by 40%. And like what we are trying is to stabilize those benchmarks. So I think like there were two things that we kind of concluded that's happening. One is either the data alignment. So let's say there were like arrays or structures in the code, and it's just like the memory allocated for that run was like not aligned, for example. And the second part is the code alignment. So now we are like trying to fix the code alignment part, where if a method, like if there is a hot method that has loop, we'll try to align it to the 16-byte boundary. If there are like multiple loops, we'll try to align the loop in with the 16-byte boundary. And that we have seen like dramatic difference like in terms of stability as well as performance. But when we see this kind of like regressions, first we try to like fix the alignment and see if the performance stays stable, or does it still show like noise. And that helps us like eliminate a lot of these benchmarks or regressions. We say that, hey, this is just like alignment related issue, so maybe like there's a like luck next time that this will not show up. It's just like bad luck that it got misaligned basically. So that's like, I think like the alignment is the key driving factor, where you'll see this kind of noise.
Yeah, you've actually reminded me about one of the talks by Emery Berger, where he was talking about the impact of even small things like environment variables, where if you, like, depending on your username, for example, which is going to be part of your environment variables that they're going to be passed to program for execution, you can totally change the memory layout of your app, and you can have a vastly different performance just from a mere fact that you're running the same exact program by a different user. So yes. He mentioned that they have special tooling that would essentially try to run the same binary using different environment variables from different directories and whatnot, trying to impact the layout as much as possible to at least exclude these false positives that are just caused by the environment variables.
Right.
So I wonder, yeah.
So I mean, yeah, like that's the another thing. Like, so for example, like the benchmark we run, like it does some kind of setup, and then it will run in a loop like 50,000 times, and then like stop the counter and then measure the time, right? So what we try to accomplish right now is like before every iteration, just allocate a like random size of array. So that would actually like give us a more bucketized timing. So let's say for one iteration, like we are just lucky and the array in the test was actually aligned properly, but for in another iteration there was a random memory allocation, and that's why like the array is misaligned. So we'll get like a different bucket of this numbers, and then we will just average out or come up with a median, and that's the range of that that performance benchmark that we actually report. So we don't we try to like average out the number of a particular benchmark by randomizing this memory allocation before executing every iteration, for example. So that's like one way to handle that case.
Right, that's an interesting point. It reminds me another story when in a lot of languages there is a seed that is used for hash functions that power things like hash tables and whatnot, so that to avoid DDoS attacks. But at the same time, the problem is that every time you run the same program, you can have a different bucketization of your data structure. So obviously you can have a very different performance implications of this, and you're not measuring apples to apples. And if your data structure is very large and every time you get a different allocation, you can have you can potentially never converge to some single reasonable metric, which is why I think it's definitely important to also consider things like hermeticity and determinism in our algorithms and applications, so that we at the very least have some sort of knobs which we can use to fix things between the executions, such that when we know what we're doing, we can have a deterministic result.
Right. I mean, like compilers do have that kind of option, I guess. So, for example, like you can, if you know like there is a performance critical code, you can add like some kind of pragma saying that align this structure or align this array at like this many byte boundary, or for GCC or LLVM have an option saying that, hey, align this all the methods or all the loops at 16 byte boundary. So when the LLVM compiles your code, like it will always align all those methods to the 16 byte boundary. So yeah, I think like compilers are giving that option, but yeah, it's up to the user to use them.
Yeah, that's awesome. It's just that I believe there are still there are always areas of non-determinism, and I remember when I was going through the code base on like linkers and whatnot, there is always someone sneakily using rand function for some tricky stuff. So you never know what you're gonna get in some of our two-chain components. But I guess that's what makes our life much more interesting.
Yep.
So this is good. Yeah. Well, I'd like to give anyone else an opportunity to speak top of their mind before we wrap up the event.
Yeah, I just think like I was mentioning, I guess like every performance investigation is like I think different in a way, like it has like a different angle, I guess, and pretty much in all the talks I've seen the theme, like they try to like come up with this profiling tool and like figure out what's hot or what's not. So I don't know, like it's very hard to come up with like a universal like tool or some kind of mechanism to say like, hey, this is the black box, whatever problem you have, just throw it into a black box and it will tell you what was the reason of the performance. The problem is so common, like every other person might be dealing with this every day basically. So
yeah, well, on this optimistic note, I would like to thank everyone who has joined us today. Really appreciate your time. Amazing content. I've learned a ton from all of you. It's been invaluable, and I hope that as an industry, we'll be able to, by realizing the commonalities of the problems we are dealing with, we'll be able to converge on the set of standards that will make our life much easier, and we'll have a rich ecosystem that would benefit all of us. So I'm very much looking forward to seeing what you're gonna do next, your next results, and I hope to see you at our next events. Thank you so much again.
Thank you, Taras, for organizing this event as usual.
Thank you.
Thank you,
Taras.
Bye-bye.
Bye everyone.